Welcome to the Blockchain Hustle. Welcome back. In my previous episode, Decoding the AI Hardware Game, I delved into the frenzy around the AI chips. What are they? Why do we need them? Who's pulling the strings in the AI hardware space? Now, in this episode, we dive deep into the AI costing and decode the magic behind those eye watering price tags. Now, before we delve into the dollars and the cents, let's demystify a couple of terms. Now, LLMs, the large language models, they're typically defined by the number of parameters and tokens. For example, we say that GPT-3 requires 175 billion parameters and it is trained on 300 billion tokens. So, what are these numbers? Parameters and tokens. Parameter. So, what you do in an LLM is that you feed in lots of data during the training of a neural network. And each of these gets a certain weight or a weightage strength assigned to it. And for a flexible model fitting, you have something called a bias. A parameter is a number that represents either the weight or the bias in the network. They basically represent general patterns of how we use words to form a sentence. Next is token. Now, when the model works with the text inputs, it first assigns a number to a text. And this process is called tokenization. Tokens basically correspond to the words or parts of words. So, parameters give you an idea of the complexity of the neural network. Token size gives you the idea of how much data was used to train that network, to train those parameters. Parameters will indicate the LLM's ability to handle diverse context, and the number of tokens defines the inherent knowledge of the model. Now let's crunch some numbers. Compute power is measured in terms of flops, floating point operations. A general rule of thumb here is that for a model with p number of parameters for an input and an output sequence of length n tokens each, training will take 6 times the product of the number of parameters and tokens. That is, training would take 6 pn flops, and inferencing would take twice the product, which is 2 pn number of flops. For example, GPT-3. GPT-3 has 175 billion parameters and 300 billion tokens. So the number of floating point operations, flops which are required for running training, would be 6 multiplied by 175 billion multiplied by 300 billion. These many flops, which turns out to be 3.15 into 10 to the power 23 flops. Now that's a humongous number. It is a computing training requirement for just one training run. That's some serious computational muscle flexing out there. So once you know your compute power requirement, you will go and look at the available AI cards like your A100, H100, and others for the performance. That is speed, power, price, etc. And then see how much does it cost to buy one or to rent one. How many cars would you require for the same? But wait, that's not all. There's more to the story than the raw compute power. Here are a few factors that play into that hefty price tag of the AI chips and the hardware. The first one is memory requirements. Now, as the AI models grow in complexity, so do their memory appetites. And these numbers would exceed the memory capacities of most of the existing GPUs and the other AI accelerator chips. So, hence, what we need to do is to split the model across multiple cards. Optimized models and the memory efficient strategies thus become crucial to avoid hitting memory bottlenecks. Then there are additional factors too, like network fabric, number of test runs that you will need before you zone into your final one. And lately, you have another thing, you have to factor in the reserve cost also. That is the price to pay for reserving your capacity with the vendor. That's what happens when the demand outstrips the supply. And all these just go on adding up to your final cost. Then there are other concerns apart from the high pricing. For example, power consumption. Now, these chips, these AI accelerators, they are hungry beasts, demanding robust cooling solutions to tame their heat emissions. So, you have to come up with some innovative techniques to keep things chill, like liquid cooling. Power is a big issue. Then there are foundry constraints. So, with the high demand and the limited foundry capacity, pre orders, reserved capacities, and locked agreements, they have become the norm, adding layers of complexity and cost. So, not only compute is expensive, capacity is also expensive. So, in this scenario, what can the Davids in this AI Goliath world do to access this computational might without breaking the bank? Well, there are a few considerations. For example, start with defining your objective. Is it training or is it inferencing? Your model size, your target fit, batch size, learning rate, duration of the training process. Each decision shapes your compute needs. Consider a flexible uptime. So, as compared or in contrast to your traditional rigid uptime models, batch processing and smart scheduling can save some cost. Then you look at optimizing your models. Trim the fat, focus on efficiency, tailor your algorithms to your specific needs. For example, if you are into inferencing, what is your usage pattern, your target latency? It's especially useful for your edge devices. Then you also need to look into the network fabric. How many cards does your job require? If multiple, then how do these multiple cards in your network work together? How much memory will you need? What is the network fabric that you're working with? What is your memory bandwidth? It's all a symphony of optimization. And then you'll need to ask yourself, own or rent? The age old question to build your own infrastructure or leverage the cloud services and rent. It's long term strategy and budget coming into play. So, why is AI compute so expensive? In this whirlwind of digits and dollars, remember, every flop counts, every parameter matters, and every token adds to the story. And it's not just the algorithms flexing their computational muscles, it's the intricate dance of hardware, demand, and the supply constraints. So, picking the right hardware isn't just a choice, it's a strategic move. So, with these two episodes, the previous one titled Decoding the AI Hardware, and this one, Deciphering the Price Tag of AI Power, we've had a rundown on who's pulling the strings in the AI hardware space. What is the deal with the supply demand dynamics and the almighty dollar? And how much dough are we talking about here? And how can the little guys wrangle their way into owning or renting this coveted tech? So, there you have it, a deep dive into the tech, the market, and the costs of the AI hardware. Hope you have found it both enlightening and engaging. Well, that's it from my side. Thank you for your attention and time. If you do have any comments or queries, I would love to hear them. You can reach out to me at minu@minusareen.com. My Twitter handle is minusareen, and my contact details are here. Of course, you can always leave a comment down in the comment box. So, till the next one, see you later. Cheers.